Hi everyone, welcome back. Today we are continuing on with part 4 of the Bill Splitter service. In the previous video, we went through the process of creating a single service responsible for splitting the bills given a list of items as well as the users who are paying for these items. So to be specific, we created this Bill Splitter service class here. And the core method that's being used is this split bill method over here. So the split bill takes in an array list of input items. And these input items contains the name, price, quantity, as well as the users who are paying for this. So this implementation got a little convoluted, so we split it into two methods. The first method is to group all of these items by users who are paying for it. And this is pretty much the hash map where the key is the name of the user and the value is the array list of input items that are paid for by this user. So for each of these input items, it is pretty much the same model that we went through earlier. So after we get this hash map, where we map an array list of items to users, we created a second method where we calculate the amount of money each user is going to pay given this hash map. So to be specific, we created getOutputUser and it returns back an array list of output users. So for each of these output users, we have the name, the total amount that they are paying, as well as the array list of items that they are paying for. So these items over here pretty much is like a receipt for justifying the amount that this output user has to pay for. So this is nice and all, but in the previous video we encountered a deserialization issue. So for better context, we spun up the application using Maven followed by Springboot run. And we made a few requests to this service to test out the deserialization logic. So now we have the server on at port 8080, and now let's try making a request to the server. So if we send a request to the server currently, it gives us a status 400. So it gives us this error over here. So as context, we set up this boilerplate using Jackson to handle the serialization and deserialization. So this current error is coming from Jackson. So in summary, I had to painstakingly look through the documentation and realize that it is happening because of two reasons. So the first reason is that for our input models, it turns out that we really don't need this annotation over here. But the mistake that I made is that for this to be used, for Jackson to create, to deserialize a JSON to the input item and input user data models over here, we either need to have at least one constructor that is empty, like it takes in no arguments, or we annotate our constructors using the JSON creator annotation. So is this specific Stack Overflow that explains a little bit better. So to be specific, if our constructors are not annotated by default, then our JSON serialization and deserialization library will need at least a default no-args constructor in order to pass the JSON into this data model. So to validate that, I will be adding on a constructor over here. So a very simple no arguments constructor. So it happens that currently from the previous video, we created a constructor that has no inputs to it. So we have one for the input items, but this input item here has an input user class as well. And it happens that for this input user class, I did not define a public constructor with no arguments. So let's do that. and I'll be calling super. Okay, in this case, I guess there's really no need for super, I guess, because there's no parent class to call. So that's it. So this will fix the first issue where the deserialization is crashing. The second mistake that I made in the previous video is that it happens that all of these models are defined inside a separate package. And for this input models, it happens that I define each of those attributes to be public. So that's fine and all. We're able to access each of these attributes like outside of this package. But the thing is, our controller and our service is outside the models package. So what this means is, if we take a look at the output items and output users and this slim output users, each of the attributes do not have an accessor keyword. So what this means is that each of these attributes are currently default, like their accessor keyword is default. And the thing about accessor keywords, default Java accessor, is that if we specify these attributes to be publicly accessible, then what this means is that we can't access these attributes outside of the package. So as you can see under the default column, if it's under the different package, we cannot access it. So this is causing issues on Jackson, like Jackson can't access these attributes, so they cannot serialize these output classes into JSON. So to fix it, we will need to make them public, because they are in a separate package from our controller and our application. So by making it public, this makes these fields detectable by Jackson, and Jackson library is able to help us serialize these fields for us. So to validate our hypothesis, I have made these two corrections. So for each of these models, we have defined for the input models, we have defined the public constructors, and these constructors with no arguments will help us with the deserialization process. My current hypothesis is that we do not need to do the same for the output models. Jackson doesn't need us to create a constructor with no arguments for the three output models: output item, output user, and slim output user. So to validate my hypothesis, I'll be leaving them as it is, and we're going to spin this server up again and see if we are able to get back a response. So for context, currently I have made the endpoint take in only one single user input item. By right, we should support taking in multiple input items, but just for the sake of testing this out, we will be checking if this works. So let's okay, so this looks fine, and let's try hitting this split view endpoint, and hopefully this fixes the serialization and deserialization issue that we encountered earlier. So now I'm spinning up the server again on port 8080, and let's see how this goes. So now it's spun up, and now let's try calling split view. And wow, as you can see, we're able to take in the input, deserialize it, process it, and give back the output. So on that note, what this means now is we can finally correct this split view over here to take in an array list of items. So let's make this an array list of input items, and we will use this directly instead. And once done, okay, we can inline the variable, and yeah, that's it. So let's try spinning this server up again, and this time we will pass in an array list of items. So we're spinning up the server again, and this time we will pass in a list of input items, and let's see whether if this bill splitter service is able to split the bill correctly. So now we have cola, and we bought 10 bottles, each costing $2. So currently we have one user, so that's only paid by Boban. So the expected result for this after sending it to the server is that we will end up with Boban paying $20. Boban will be responsible for paying for all of that. So let's make the request, and as you can see, we get back an array list of users, and Boban is supposed to pay $20. Let's try adding in another user, and let's call this Arnie, I guess. And let's call this again. And as you can see, like, the bill splitter service was successful in splitting the bill correctly. Let's try adding a few more items. And let's say that aside from Boban and Arnie splitting the cola, let's say they bought some cheese as well. And they bought cheese at $5, and they bought 10 of them, but this is only paid by Arnie. So the expected result would be Boban paying $10 for just the cola, and Arnie will pay $50 for the cheese and $10 for the cola. So that should give $60 for Arnie. So as you can see, Arnie pays $60 as expected, and Boban pays $10. So yeah, that's pretty much it. Like, I'm really happy that we were able to get the bill splitter out in one try. Just the logic itself, I was struggling a lot with the serialization and deserialization. But yeah, let's take a step back. And previously I mentioned that the reason why the deserialization was having issues was because Jackson needed at least one constructor with no input arguments. So that is if the JSON creator annotation is not on the constructor. So some of the smart parrots out there would ask what would happen if we annotated the constructor with JSON creator instead of creating these constructors. So specifically on input item and input user. So to validate that, I will be deleting this no argument constructor and annotating our existing constructor with the JSON creator annotation instead. And as you can see, like, this annotation is from Jackson, and this Jackson library is imported inside as a dependency when we generated the boilerplate. So that's why we happen to have that package ready for us to use. So let's delete this as well for input item and give the JSON creator annotation as well. So to validate the hypothesis that adding the JSON creator annotation would allow Jackson to deserialize the JSON into input item and input user, as we define over here, I'll be spinning up the service again, and let's see whether if Jackson is able to deserialize this for us. So now I'm spinning up the application again. And okay, it's up. And now let's make a request. And there we go. It works. So that's pretty much it. We were successful in fixing the serialization and deserialization with a lot of Googling. And we got a very simple service up. Like, some reflections. After looking through the Jackson documentation, I realized that there's really quite a few things that we have yet to explore. So in production, there's likely scenarios where you need more granular control over the serialization or deserialization. There might be times when you want certain fields to be serialized or deserialized in a specific order. You might need to define custom serialization and deserialization logic. And in this case, we did not get to visit these concepts yet. So in summary, what I'm trying to say is that this project really scratches the surface of what you explore in the Springboot framework, as well as how Spring Boot uses Jackson to handle these things. We have also not talked about persistence of data. We have not talked about caching, and we have not talked about making API requests to another separate service. So pretty like this project is pretty small. So there's more coming up. I'll be exploring some possible projects to share these concepts and possibly even get into making efficient calls to databases and servers using thread pool executors, using multi-threading or async. But anyway, these are the possible things we can continue on with this. And if you have any ideas or any projects that you would like to see, please leave them in the comments, and thank you so much for watching. So with that, that's it for this series. I'll be uploading this code to GitHub so that you can take a look, and that's all I have. So with that, thank you so much for watching, and I'll see you in the next series.